Moving on to the next part of our discussion on wave motion, let's take a look at the concept of Doppler effect. It's been observed that when there is relative motion between the sound source and the listener, the frequency heard by the listener is different from the frequency emitted or produced by the source. The listener will hear a frequency that is either lower or higher than that produced by the source. This effect or phenomenon is referred to as the Doppler effect. Say you have a sound source and a listener. The sound source is on the right, the listener is on the left. Sound source is moving to the right at speed Vs, and the listener is moving to the right at speed Vl. The source produces a sound. It emits a frequency, Fs, frequency emitted by the source. The sound will travel towards the listener, eventually reaching the listener. The listener will hear a sound of frequency Fl, frequency heard by the listener. The relationship between Fs and Fl is given by Fl is equal to V plus minus Vl all over V plus minus Vs multiplied by Fs. This equation is known as the Doppler effect equation. V is the speed of sound in whatever medium there is. Vl is the speed of the listener. Again, the listener is moving to the right at speed Vl, and Vs is speed of the source. And again, the source is moving to the right at speed Vs. It's important to note the direction of the velocities or motion of the source and the listener in terms of this figure, because that will come into play with the plus minus sign in the equation. Plus minus, use minus sign if the object is heading in the opposite direction as indicated in the figure. For instance, the listener in the figure is moving to the right at speed Vl, but if the problem presents a situation wherein the listener is instead moving to the left, use minus sign. So, V minus Vl. The same goes for the source. The source in the figure is moving to the right. If the problem presents a situation wherein the source is instead moving to the left, use minus sign. So you have V minus Vs. And note that in the figure, the source is on the right, the listener is on the left. If the problem presents a situation wherein the position of the source and the listener are reversed, the listener is on the right and the source is on the left, you need to adjust the situation so that you'll be able to use the equation. Meaning, you must move the source to the right and the listener to the left and adjust the corresponding direction of their velocities, of their motion, so that the situation will now be suitable for you to use the Doppler effect equation. Fl is equal to V plus minus Vl all over V plus minus Vs times Fs. The listener is on the left, the source is on the right, and both of them are moving towards the positive x direction or to the right. The default situation as shown in the figure. If the relative motion between the source and the listener is toward each other, the frequency heard by the listener is higher than that produced by the source. There is what is referred to as an upward frequency shift. On the other hand, if the relative motion between them is away from each other, the frequency heard by the listener will be lower. You have a downward frequency shift. Sound is a wave that travels in all directions away from the source. Sound exhibits Doppler effect. Any wave that travels in all directions away from the source will also exhibit Doppler effect. Case in point, electromagnetic wave or light is a wave that travels in all directions away from the source. Light has also been observed to exhibit Doppler effect. And that's it for now. That's it for our discussion on Doppler effect. We'll continue our discussion on wave motion in the next video, wherein we take a look at the concept of beat formation. So again, that's it for now, and thank you for watching.